Hello, class. So we are going back now, finally, to section 10.7, which is about partial fractions. Okay, so specifically, it's actually called partial fraction decomposition, but everyone just kind of calls it partial fractions. So basically, we remember back in chapter 1, right, we learned how to add fractions, right? So if I gave you this thing, you could add it, right? You would find like common denominator, right? So it would be multiply both of them together and simplify the top, and you get 2x squared minus x minus 1, okay? So, right, we remember how to do this. Now, the other thing is remember that we can split a denominator like this, right? This is totally fine, okay? But recall that we have like a problem, right? If I have the opposite thing, so x plus 1, x minus 1, right? We cannot do this, right? This does not work. Or I mean, we cannot split the denominator, okay? We would like to be able to do something like this though, okay? Or go backwards, right? If I have this thing, can I go back to splitting it? And that's what partial fractions is all about. And really, we're gonna have 4 cases. The first 2 are the most important, and that will show up on tests. All right. So case 1 is distinct linear factors. Okay. So distinct linear factors. So this means that when you have a function, a rational function, right, p of x over q of x, right, it's equal to some stuff. Very specifically, q of x is going to factor into something. All right, we don't really know what. It's our job to factor it, but that's not the problem. ANX plus BNX. Okay, so Qn factors into a whole bunch of linear factors. The goal is we want to be able to have each factor be its own fraction, right? So we're going to split the denominator by every single term. One, okay. Or something, actually. These should not be ones. These should be R1x. Okay, we don't really know what R is. Our goal is to kind of find R. Okay, and so how we do this is we actually need matrices, supposedly. Okay, so let's do our first example. Okay, so we have this rational expression, x cubed plus 2x squared minus x minus 2. Okay, so remember, step 1 is always, doesn't matter what case you're in. Step 1 is to always factor the bottom. Okay, so hopefully you remember that this requires factor by grouping. Okay, so you're gonna take out a minus sign. This is going to equal 5x plus 7, x squared minus 1, x plus 2, which gets you 5x plus 7, x plus 1, x minus 1, x plus 2. So I have factored the bottom into its distinct linear factors. Okay, and what we're going to do is we're going to try and find the partial fraction decomposition. So what we're going to do is just put letters here. And our goal is to find what is A, B, and C. Okay? Now, what you do is we then try and solve this. Okay, so what we're going to do is multiply both sides. Okay, we're going to multiply both sides by the denominator. So x plus 1, x minus 1, x plus 2. Okay, and if you're good with being able to cancel properly, you should get x minus 1, x plus 2, b, x plus 1, x plus 2, and c, x plus 1, x minus 1. Okay, so if you distribute that to all four of these terms, we get here. All right, so then what you're gonna do is FOIL everything out, sort of. Okay. So this 5x plus 7 is gonna stay here. This is gonna be a x squared plus x minus 2. This thing in next to the b is gonna be x squared plus 3x plus 2. And the c term is gonna be x squared plus, just kidding, x squared minus 1. Okay. Then you're gonna distribute the constant. Okay. So you're gonna get 5x plus 7, ax squared plus ax minus 2a plus bx squared plus 3x plus 2b plus cx squared minus c. Okay. And what you're gonna do now is you're gonna group them by term. So you're gonna get all of the x squareds together, all of the x's and all of the constants. So actually, I'm gonna rewrite this as a plus b plus c x squared plus a plus just kidding, 2b, wait, no, 3. I forgot the b, 3b. 3b x plus negative 2a plus 2b minus c, and that's what we get. All right, and then since they're equal, right, that means they should be equal, which means if we compare coefficients from the left and the right hand side, right, this one doesn't even have an x squared, right, so it's 0x squared. So you should get a plus b plus c equals 0. If you compare the linear terms, you get a plus 3b equals 5. And then if you compare the constant terms, you get negative 2a plus 2b minus c equals 7. And this is a system, right? And this is why this is in chapter 10, because now you have this augmented matrix. Okay, which you should know how to solve, right? So I'm going to solve this. I'm going to do row 2 minus row 1, row 3 plus 2 row 1, 1, 1, 1, 0, 0, 0, 2, negative 1, 5. So I'm going to multiply by 2 and add. So that's going to give me a 4. It's going to give me a 1. That's going to give me 7. Okay, now I'm going to do row 3 minus 2 row 2. 1, 1, 1, 0, 0, 2, negative 1, 5, 0, 0. Okay, so I'm multiplying by negative 2. So it's going to give me positive. So it's going to be 3. And then negative 2, so that's going to be negative 10. So that's going to be negative 3. And now I'm done, right? So now I can start back substituting. So z equals negative 1, which 2y plus 1 equals 5. So 2y equals 4, so y equals 2. And then plug into the top one. X plus 2 minus 1 equals 0. X plus 1 equals 0. X equals -1. Ta-da! Oh, this should be all in ABC. My bad. So yeah, so that means A equals -1, B equals 2, and C equals -1, which implies 5x plus 7, x plus 1, x minus 1, x plus 2. This is equal to -1 over x plus 1 plus 2 over x minus 1 plus -1 over x plus 2. And ta-da, you have found the partial fraction decomposition. Okay, and this is how you're supposed to do it. It's just, this always works, okay? All right, now, all right, I want to make this a huge deal, big deal, all right? If you learn one thing from me in this entire class, okay, if this is the one thing you learn from me, this is, I'm happy, okay? Everyone teaches partial fraction decomposition this way, and I really don't understand. Because, right, like if you look at it, it's like a lot of work, okay? Like this much effort. All right. I learned it, I think, just the better way, which is why I call this the better way, okay? So, I'll just show you it with the same example. Okay, so we have this thing. Okay, so remember, right? A, x plus 1, B, x minus 1, C, x plus 2. Okay, right? When we multiply everything by x plus 1, x minus 1, x plus 2, we get here, right? A, x minus 1, x plus 2. B, x plus 1, x plus 2. And then C, x plus 1, x minus 1. Okay, and then here's the magic part, is, right, this has to be equal, because there's an equal sign here. So that means we're allowed to just plug in x's, okay? And so if you're smart, you should plug in very specific x's. Like I'm going to plug in, okay? So I'm going to plug in x equals 1. And look at what happens. I'm going to get 5 here, okay? Well, I'm going to get 5 times 1 plus 7. But what happens here? That's 0, right? And here I'm going to get 2, right? 1 plus 1 is 2. And then 1 plus 2 is 3. But then over here, very specifically right there, right, I'm going to get 2 times 0. So actually, 5 plus 7, so that's going to be 13 equals b times 6. Okay. Am I wrong? I'm totally wrong. This is 12. Excuse me. 12. Which means b equals 2. Which it did. Okay. Right, and that wasn't hard. Now I'm going to plug in x equals -1. Look at what happens. You're going to get a -5, right? So you're going to get 2 over here. If you plug in -1, okay, you're going to get a -2, 1, plus, look, now this thing is 0, so I don't care. And this thing is 0, so I also don't care. So this is the magic, all right? If you plug in zeros, all of the letters are going to cancel, so you just automatically get an answer. Right here, 2 equals -2a. That means a equals -1. Ta-da, we're done. Okay, and then for the last one, plug in x equals -2. Okay. What happens, right? This is going to cancel. This is going to cancel. And you only have to plug into the thing in front of the c. So -10 plus 7, that's going to be -3. And then c times -2 plus 1 is going to be -1. -2 minus 1 is going to be -3. So c equals 1. -1? 1. No, -1. Ta-da! And we're done. Okay, and look, we got the same answer. Okay, so I highly, highly encourage you to do this way. All right, it's way easier. Okay, so let's do one more example. Okay. So we're still in case 1. Okay, but let's do another example. Okay, so let's go like 2x plus 1 over x plus 1, x minus 1, x plus 2, x minus 3, x plus 4. Okay, so this, if you did it the way the textbook would want, would be a 5x5 system of equations. Which, right, we remember that a 3x3 is already annoying to deal with, right? So we don't want to do that, okay? So instead, I'm going to do this my way. Okay, so first you got to set this up regardless of which way you choose, right? So you're going to get, all of them are distinct linear factors, x plus 4, okay? And this is going to be like a lot of writing. Okay, but 2x plus 1, right, after I multiply both sides by the denominator, I'm going to get a, and then the only thing that's left, the one that cancels is x plus 1, so it's going to have all of the other ones. So x plus 2, x minus 3, x plus 4. I probably should have made a smaller example. X plus 1, x plus 2, x plus 3, it's x minus 3, excuse me. X minus 3, x plus 4. I don't think there's space. So C, x plus 1, x minus 1, x plus minus 3, x plus 4, plus D, x plus 1, x minus 1, x plus 2, x plus 4, and then the last one plus E, x plus 1, x minus 1, x minus 3, x plus, oh, just kidding, x plus 2, x minus 3. All right. And now I'm just going to pick the numbers that are special. So I'm going to pick x equals 1. What happens? I'm going to get 3 equals. The only one that doesn't cancel out is this one, right? Because that's 0, that's 0, that's 0, and that's 0. Okay? So all of the other letters are going to cancel. And I'm going to get B, 2, 3. 1 minus 3 is -2. And then 5. So this means B equals, okay, so the 3's cancel at least. So you're going to get 1 over -20. Okay. So that's B. This is going to have really bad numbers because I made this example up like literally on the spot right now. Okay. Okay. So there you go. That's one of them. Now I'm going to pick x equals -1. X equals -1. Okay, so what happens is I'm going to get -1 on the left. And then, right, this is 0, this is 0, this is 0, this is 0. The only one that doesn't cancel is A. So A is going to get me -2, 1, -4, 3. Okay, so we're gonna get we are going to get 12/24, so we're gonna get A equals -1/24. Okay. Now I'm gonna pick x equals -2, I guess. All right, so then again, that means the only one that doesn't cancel is gonna be the C, right? This one. So -2, so if I plug that in, so it's gonna give me -4, so that's gonna be -3 equals C. This is gonna be -1. This is gonna be -3. This is gonna be -5. This is gonna be 2. So the -3's cancel. And C is 1/10. Yep. All right. So then pick x equals, I think this one should be just be 3. Yep. Okay, so 3, so we're gonna get 6 plus 1, so we're gonna get 7 over here. And then I think D, right? Yep. So I'm gonna zoom out here a little bit. So plugging in a 3 is gonna get me 4, 3, 5, 7. Thankfully, 7's cancel. So what's a big number? 2060? Yeah. Yeah. Okay, so D is 1/60. And then finally, we get to the last one, 4, or should it be -4? It should be -4. And so -4 is going to give me -8 plus 1, so -7. And then E is the only one that will be left, so E, -3, -5, -2, -7. So those cancel, thankfully. And you get -30. So E equals -1/30. And then if this was a real question, you should rewrite, like plug in A, B, C, D, E, and box this, and that'll be the answer. But that's a little too much work. Okay. All right. But this is still better than solving a 5x5 system, I think. Okay. So there we go. All right. Now for case number 2. Okay. So case 2 is when we have repeated linear factors. So this one is less easy, okay? So this means we have something like this. Okay, so here's an example. X squared plus 1. Here I'm going to have x and x minus 1 squared. Okay, so we notice this is the repeated linear factor, right? We have x minus 1 there twice, right? Like really, this is x squared. X squared plus 1. This is x squared plus 1, x minus 1, x minus 1. Okay, so this one is here twice. Right? What do we do is it's almost the same. So this x is the same. Right? It's just going to be a over x. What happens is you need to do this twice. Okay, so you're going to get a b x minus 1. But since it's here twice, you're going to need a c x minus 1 squared, okay? And if it was here 3 times, you would just do it again, right? Okay. But now, it's the same thing. So you're going to get x squared plus 1 equals a x minus 1 times x minus 1 squared plus b x minus 1 that's it. Okay, And then C X. All right, let me just like you're gonna multiply by x minus 1 squared. Okay, so when you distribute, the x cancels. Okay, that's what I thought. It was weird. I was a little confused. Yeah. There we go. That's much more normal. Okay. So yeah, when you distribute there and you distribute there and you distribute there and you distribute there. Okay. Alrighty then. Okay, now see, here we have a problem though. Okay, the problem is my trick becomes much less good. Okay, so I'm going to pick x equals 0. You're going to get 1a negative 1 squared. And then this will cancel and this will cancel. So you get a equals 1. Okay? But notice this problem. Now I'm going to pick x equals 1. Okay, so you're going to get 2 equals. This is 0. This is 0. So c equals 2. Never mind. So my trick is not as is still good. All right. But now, okay, I'm out, right? There isn't a special number that I can plug in to figure out what b is. Okay, is the problem. Right? So what I'm gonna do is now I'm gonna plug in a and b. Okay, because I need to figure out what b is. I mean a and c. So I'm gonna plug in a and c and see what happens. So x squared plus 1 equals x minus 1 squared plus b x minus 1 plus 2c. Okay. Oh wait, no, plus 2x. There we go. All right. And so from here, we can just solve for b. Okay. Specifically, I'm going to solve for b by looking at the leading term. So right, we know that the leading term here is going to be x squared, and this one's going to be bx squared, and this one doesn't even have an x squared power. So if we're just comparing x squared terms, we should have 1 equals 1 plus b, which means b equals 0. Okay. Alrighty then. The other thing you could do, if you don't want to like partial FOIL and compare terms, is you could just pick a different x. Okay, so I could plug in like x equals negative 1. The only thing is that doesn't help me as much as it used to, right? Because I'm gonna get 2 here. I'm gonna get right, negative 2 squared plus negative 1, negative 2 plus 2 times negative 1, right? So I have to do a little bit of work now, actually. Okay, it doesn't just super cancel. So I'm gonna add the 4, add 2 over, I mean, excuse me. Right, but we see we get the same answer, right? 2b equals 0, so b equals 0. Okay. So with the repeated linear factor case, basically you can't just plug in special x's and get all of the answers. Eventually you're going to need to solve something, okay, to find the last one. Okay. All right. So let's do one more example of the repeated linear. So here I'm going to have 2x plus 1 over x minus 1 squared x cubed. Okay. So again, this is a big one, right? So we're going to have, right, a x minus 1 plus b x minus 1 squared plus c x plus d x squared plus e x cubed, right? Because you got to go all the way up to the multiplicity or the power. All right. Now, 2x plus 1. So if we multiply by the denominator, right? X minus 1 squared, x cubed. We're going to get a x minus 1 x cubed plus b x cubed plus c x minus 1 squared x squared plus d x minus 1 squared x plus e x minus 1 squared. Okay? And again, if you want to do it the book way, you would FOIL all of this out and compare coefficients. But I would highly advise you to plug in some numbers first. Okay? Because even like worst case scenario, you can make this 5x5 system, which is what you would have if you just did it right now. You can at least make it a 3x3, which is much better, right? So I'm going to pick x equals 0 and plug that in, right? So this is 0, this is 0, this is 0, this is 0. So the only one that is not 0 is e. So you're going to get e. Ta-da! Okay, so you're going to save that one. The only other good x is -1. Oh, just kidding. I mean +1. So x equals +1. So then this cancels, this cancels, this cancels, this cancels. The only one left is b. Okay. So what you get, okay, so plug in +1. What am I doing? Positive. Okay. So you're gonna get b, 3. B equals 3. Ta-da. Okay. And now is when we have to figure out A, C, and D. Okay. All right. So I'm actually gonna figure this out. Okay, the hard way. So what I mean is I'm gonna plug in some x's. Okay. So I'm gonna plug in x equals -1 and get an equation. So I'm gonna get 1 equals. So if I plug in -1, what happens? I'm gonna get -2. So I'm gonna get 2a. Plus, just kidding. -3 because I already know what b is. Okay. Plus c times, okay, -2 squared. So it's gonna give me a 4, and then that's a 1, so it disappears. Plus d times 4, but a minus sign. And then e is 1, so I don't care. And then -1, so it's going to be 4. Okay. So 1 equals 2a plus 4c plus, just kidding, minus 4d. And then this is actually 1. So I'm going to subtract 1 to both sides and get the actual equation. Okay, and I'm going to box this in. So I need to save that one. And now I need 2 more equations. Okay. Now, the other equation that you would get is I'm going to compare the leading term again. Okay. So I'm going to compare the x to the 4th power term because I can partial FOIL, right? This leading term is going to be a. This one doesn't have a 4th power. This one is just going to be c. This one doesn't have a fourth power, and this one also does not have a fourth power. Okay? So actually, and this over here doesn't have a fourth power either. So you get 0 equals a plus c. Okay, which that one's nice. So that's what you get for comparing the x to the fourth power terms. All right, now you kind of have to pick your poison to get the third equation. Either you would compare coefficients again, but with the x cubed term, except now this time it would be a little more complicated to calculate. Okay? Because you would actually have to FOIL these two terms, the one with the a and the c. Okay? Now, what I'm actually going to do is I'm just going to plug in another x. Okay, so I'm going to plug in x equals 2 because I'm running out of all the good numbers. Okay? So if I plug in x equals 2, I'm going to get 5. And then I'm going to have to zoom out. Okay? So if I plug in x equals 2, I'm going to get 1 times, so I'm going to get 8a plus 3 times 8 plus so 2, so it's 1, so it's 1, some 4c plus 2d plus e, which is actually 1. All right, so that wasn't too bad, I guess. I've 3 times 8. That is going to be 24. Okay, so it's going to be 25. So we're going to get negative 20. 8a plus 4c plus 2d. And there we go. We have our 3x3 system. Okay. It's going to be, I'm just going to, let's do them in order. So 2a, 4c, negative 4d, 0. 1a, 0, so c. So 1c, 0d equals 0. And then 8, 4, 2, negative 20. Okay. And then I guess I'll go through the horror of solving this. Okay. First of all, let's divide row 1 by 2 and row 3 by 2. Okay. So we're gonna get 1, 2, negative 2, 0, which is nice. 1, 1, 0, 0. You're gonna get 4, 2, 1, negative 10. Okay, so these are smaller numbers. What I'm gonna do is I'm gonna do row 1 minus row 2 and row 3 minus 4 row 2 because I like row 2 more than row 1 actually. So 1, 1, 0, 0. So I'm subtracting, so we get 0, 1, negative 2, 0, and then 0 because that's the point. But then I did a negative 4, so this is going to be negative 2. That's 1. And then this is negative 10. Okay? All right. So then I'm going to do row 3 plus 2 row 1. Okay. So 0, 1, negative 2, 0, 1, 1, 0, 0. And then this is going to be 0, 0, negative 3, negative 10, and then I'm done. Right? D equals 10 over 3. What does that mean? Okay, so that means C minus 2 times 10 over 3 equals 0, which means C equals 20 over 3. And then the last one is A equals, well, okay, A plus C. So A plus C equals 0. So that means A equals negative 20 over 3. And there you go. There are the last 3 answers. Okay? All right. So, horrible example. But there you go. All right. Okay. So now we go to the not as important ones. Okay. All right. So first case of the non-important one, so case 3, is when you have it distinct. Okay, distinct irreducible quadratics factors. Okay, so what do I mean? I mean this. Okay, so the example is we have this thing. X cubed plus 4x, right? So if we factor the bottom, we get x squared plus 4, right? This is irreducible, right? This doesn't factor, right? Well, I mean, it does factor, but it gets you like 2i minus 2i, right? And we don't want to go into complex land, okay? So that means it's stuck like this. All right, so when you have an irreducible quadratic factor, what changes? Okay, so first of all, the x is the same. Okay, so this is going to be a over x. That's the same. Okay, what changes though is because you can't factor the bottom, okay, the top of this one is not just like b. Okay, it's actually bx plus c. Okay, so it's going to be a line, right? This is a line. Okay, so when you have irreducible quadratics, you get lines on top, not just you know, numbers. Okay, but besides that, you do everything the same. Okay, so this is the same. So 2x squared minus x plus 4 is going to be equal to a x squared plus 4 plus b x plus c, okay, times x. All right, and you can still solve this pretty nicely. Again, with the first term, so x equals 0, right? You get 4 equals, this cancels. So you get 4a, so a equals 1. Okay. But now, all right, you're kind of stuck, right? How do we figure out the b and the c? All right. Well, you have to do what you're supposed to do. So you have to do what the book wants you to do. Okay. So I'm going to plug in the a because I already know it, right? So x squared plus 4. This I'm going to distribute now. Okay. So bx squared plus cx. Okay. And I'm going to compare coefficients. Okay. So I know 2 equals 1 plus b. So that means b equals 1. And then I'm going to compare the linear term. Negative 1 equals c. Ta-da, that was easy. Okay. So, again, remember which one's b and c also, okay? Because the order matters. Okay, one is a coefficient on x and one is a coefficient by itself. So the answer is going to be 1 over x plus x minus 1 over x squared plus 4, okay? All right. Okay, now, if you hate doing what the book wants you to do, okay, a professional tip, okay, do not attempt at home, okay? This is for professionals only, all right? You notice how, like, right, the trick I've been teaching you guys is to plug in special x's, right? Well, what if you do plug in the complex number 2i? Then what happens is, right, you're gonna get, right, like, so 2i squared is -4, right? So -4 so yeah, -4 with this 2 is gonna give me -8. Minus 2i plus 4 is equal to, and then, right, this is 0. So you're gonna get plus -4b plus 2ic. Okay. So then you're going to see -4 minus 2i is equal to -4b plus 2ic. And then if you compare real parts, right, real parts, you get b equals 1. And if you compare the imaginary parts, you're going to get c equals -1. And that is a do not attempt at home. But if you wanted to know how to do it, you could do it this way. Okay, this is a extremely fancy version. All right, very few people on the planet actually know how to do it this way. But again, if you wanted to do it, go ahead. All right, and then lastly, case 4, which this one is just really not important. Okay, but repeated irreducible quadratic factors. Okay. All right. So for this one, I'm just gonna do like a tiny example because this could get really bad. This was by far the worst kind of case. So I'm gonna do just 1 over x squared plus 1 squared. Okay. So what you have to do is it's x squared plus 1 ax plus b plus a squared x squared plus 1 squared cx plus d, right? So you see that, right, just this little term right here made 4 letters pop up, right? I would have to solve a 4x4 system to get the answer to this, okay? So, let's, I'm gonna do it the hard way. So we get 1 equals ax plus b, x squared plus 1, and then cx plus d. That's it. Okay. All right, so we're gonna FOIL everything out. So ax cubed plus bx squared plus ax plus b plus cx plus d, okay? And now I have to compare all the terms, okay? So compare the x cubed, and I'm going to get 0 equals a, so that's nice, okay? Then I'm going to compare the x squared terms, and I'm going to get 0 equals b, also amazing. Then I'm going to compare the x terms, and I'm going to get 0 equals a plus c, which is nice because that means c is 0 right away. Then I'm going to compare the constant terms, so like x to the 0 power, and I get 1 equals d. Oh, wait, no. 1 equals b plus d. Which that means d is 1. And there you go. So the partial fraction decomposition of this thing is actually itself. What? How did that happen? That's bad. How did confusion? I am a bit confused. Did it just magically not work? Did I FOIL incorrectly? Or is this too simple? No, we're good. We yeah, no, we're fine. Yeah, no, it's actually just turned out to be way too simple. This was too simple of an example. All right, but it doesn't matter because this example will not show up on your test. Okay. All right. But this is how you do it though. So like maybe I should have made a 4 here so it's at least a little bit different. Or like at least an x plus 1 here. But again, what I want to say for this section is case 2 and 1. All right, those are the ones you need to know how to do. Okay, distinct linear factors, and then when they're repeated. All right, those are by far the most important. The other two, they're okay. All right, and you can do it my way, or you can do it the normal way, or you can do it a different way. Like, go ahead. There's lots of tutorials for partial fractions. This is a pretty big topic. All right, you can do it any way you want. Just make sure that you get correct answers, okay? But that's it for this section. See you guys next class.